I'd like to make a few comments about how you should respond when you're given a statement written out in symbols. Your response to that statement will depend upon if you wish to merely read what it says versus if you want to write a proof of it. So here's an example. Suppose you're interested in the statement, the limit statement. The limit as x goes to 7 of 3x squared minus 10x minus 2 equaling 75. So that happens to be a true statement. So begin by writing out in symbols what it says by making use of the working definition of limit. Put your video on pause and go ahead and do that. Okay, so this is the actual working definition of the above statement written out in symbols. So it consists of a few parts. The first three parts of it consist of the introduction of the variable names, quantifiers associated with them, and their universal sets from which they're taken. The last part is this part here, which is a certain conditional statement, where this is your hypothesis and this is your conclusion. The order in which the variables are introduced is absolutely crucial, and the statement would have a completely different meaning if, for example, you interchange the order of the introduction of the delta versus the introduction of this real number x. Now, if you're merely interested in reading what the above statement says, how would you do that? How would you read it? So put your video on pause and think about how you would read exactly what you see, and make sure that you read from left to right. So this is how I would read it, and let me point to what I'm looking at as I read it. So when I see this, I say, for every real number epsilon, for every positive real number epsilon, there exists a positive real number delta such that for every real number x, if the absolute value of x minus 7 lies between 0 and delta, then the absolute value of 3x squared minus 10x minus 2 minus 75 is smaller than epsilon. Okay, that's how I would read what it says, not how I would respond if I wish to prove it. Now suppose instead your interest is in actually writing a proof of the above statement. How would the proof be written? What would be the outline of that proof? So as you see each of these symbols, how would you respond in your proof? Okay, so put your video on pause and see if you can write out an outline of the proof. And do it by reading from left to right and responding as you get to each of these statements in the appropriate way. Okay, so here's the outline of the proof, and as I read from left to right, when I see this, I do not say for every positive real number epsilon, but instead I say let epsilon be a given positive real number. And when I get to this, I don't say there exists a positive delta such that, as I did above, but rather I say choose delta in the following way, and then I have to figure out a concrete way of choosing that delta. When I get here, I say let x be a real number, and when I get here, assuming that I want to write a direct proof, I would say suppose this happens, and then I have to prove, so that's going to take a number of steps, I have to prove that this actually happens. And so what I've intended here is I write down, I say then, and then I start on the left side, and then these dots consist of an actual argument, a proof, that we can ultimately prove that it's smaller than epsilon, and that proof would consist of a string of inequalities, each of which I know to be true, not something I wish to be true, but I know to be true, ultimately terminating in being able to say that it's smaller than epsilon. So one other point I want to make is that when I am writing a proof of this statement and I see something like that, and I say, let epsilon be a given positive real number, I have no control over what that number is. I can't make any assumptions about it other than it's just simply some generic positive real number. Think of it as my opponent in this process is giving me this challenge of this number epsilon. And the thing that I do have control over is the existence statement, because I have to choose a delta in response to the epsilon that was just given to me. So that one has to be an absolutely concrete choice. And the choice of it can only depend upon what I have at my disposal, and what I have at this point in the proof is just simply this positive number epsilon. I don't have anything else. There is nothing else that's on the table. Okay, so at the end of 2 steps, we have this epsilon that was given to me. We then have this concrete delta that I have chosen. And now someone hurls another challenge at me. They give me some real number x. Okay, but until they do that, there is no x in the problem. Okay, so at the end of 3 steps, we have 3 things. We have an epsilon that was given to me. We have a delta that I've just finished choosing. And now we have a real number x, which was given to me by my opponent. And what am I supposed to do with those 3 objects? I'm supposed to assume that the x that was just given to me and the delta that I chose in the second step are related by this. Now I get to assume that this is the case. And I have to prove that this actually happens. Okay? And the difficulty is just simply figuring out how to have chosen that delta initially, so that at this stage I really am able to prove that this happens. So that's the hard part. You have to figure out what was the proper choice of this delta so that the rest of this will actually work, so that I will be able to prove that. So I'll talk about how one chooses that delta in the next video.